Okay, so welcome to session 1 for crop and livestock. In this session, we're going to have a look at some of the research done and give you a good introduction to the energy efficiency environment. Please make sure you've got your workbook ready to follow along, and let's get started. So in this session, we'll have a look at some aspects of sustainability. We'll have a look at the research for all of WA agriculture and your particular industry. We'll focus on a financial example and why energy efficiency is important to your farm's profitability, and then we'll have a workshop session in which we'll look at your farming situation and what you're doing to manage energy. So in the Farm Energy Project, we approach energy management from a sustainability point of view, especially that social and economic side. Socially, you need to put across the business case to other people in your family or others on your farm as to why energy management and reducing electricity, diesel, ULP and LPG is really important. From an economic point of view, we focus on reducing costs and energy demand without affecting production, because that's where the real changes to your profitability will come from. So sustainability on farm has a huge range of benefits financially, operationally, and environmentally. As you can see there, more productive use of labour is a huge one. Farmers can take on average, around 30 projects a year. So it's really important in this workshop that we focus on looking at those energy reducing projects which are of the best value to farmers, because you can't take everything on at once and you really need to prioritise which will be best for you. So let's touch on some of the trends that have come out of the research, the USQ report. Rising energy prices are a reality. Diesel is on the rise. At current, Australians use around 38 billion litres of fuel a year, and that's split 19 ULP and 19 billion litres of diesel. So I want you to pause the video for a second and reflect. What is the first diesel price you can remember? In this workshop, we will focus heavily on diesel as the primary energy source across all the case studies undertaken by USQ. At 87%, you can see it should be our major area of focus. 7 case studies were undertaken in WA across a range of industries. As you can see, diesel was the primary energy source in all of those case studies. Horticulture was the only industry that varied a bit, with more electricity use for cool rooms and packing sheds. In terms of energy cost across all case studies in WA, once again you can see diesel is the highest there at 83%, as you'd expect. In terms of greenhouse gas emissions, you'll see that whilst diesel is still the highest there, electricity is quite significantly represented, given that it does emit more greenhouse gases as an energy source. So in that sense, you'll see here in this table that electricity use emits over 3 times the greenhouse gases that diesel does. What you also need to take into account though is that electrical motors run far more efficiently than diesel motors. A diesel motor will run between 35 and 45% efficiency, while an electricity motor runs at 95% efficiency. Now it's time to look at crop and livestock as an industry in particular. When we approach mixed farming, from an energy perspective, we audit livestock and grain as separate enterprises. Synergies do occur though, and they are recognised in some of the research. Let's have a look at cropping first. Cropping, as an operation, uses 4% more diesel than the WA agricultural average in the case studies. This is because cropping is a highly diesel-intensive operation. So diesel in cropping is also a higher cost than the WA agricultural average. And once again, the greenhouse gases emitted by cropping is slightly higher than the agricultural average. If we take a look at livestock, you'll see that case study B uses slightly more energy in each unit across the board than case study D. We do need to take note, however, that case study B also produces more kilos of greasy wool per hectare, and for that reason, the research not only takes into account energy per arable hectare, but also energy per tonne of grain or kilo of wool produced. In line with that then, case study B uses more dollars per hectare in energy than case study D. But once again, we need to take into account they produce 25 kilos of greasy wool per hectare as opposed to 15. In terms of energy efficiency, the engineers at the National Centre for Engineering in Agriculture have pointed out that mixed farming operations have less scope for energy efficiency projects than specialist grain. This is due to the increased affordability of capital equipment associated with the increased area of cropping for specialist grain. The project identifies a number of measures that mixed farming operations can undertake to reduce energy. However, the more area you have attributed to your grain operation gives you a higher economy of scale in considering capital projects to reduce energy on farm. So in summary, when we approach mixed farming, we look at grain and livestock as separate systems for energy use. The livestock component is less energy intensive, so there's less scope for energy savings there, and capital expenditure affects the viability of energy saving projects in a lot of cases. So that's a broad overview of energy use in WA agriculture as a result of the USQ research. And we've established that energy is a significant operational cost. But where do you start looking at energy use on your own farm? As you can see, we've got 4 main areas we focus on in the farm energy project: measurement and benchmarking, energy source changes, tariffs and costs, and finally energy demand reductions through changes to practice or infrastructure. But you've got lots on your plate as a farmer. You're probably wondering, what's in it for me? Let's have a look at a financial example. So as you can see, we've got a set of base farm financials on our left-hand side. On our right-hand side, if we decrease the variable cost by just 1% to 59.4, that will increase our gross profit by 1.5%. Our fixed costs stay the same, but suddenly our net profit becomes 4.6%. That's an increase in net profit of 15%. And sure, you could also increase your net profit by increasing the amount that you grow. But as a producer, what do you have more control over? Increasing your income or decreasing your costs? So we've had a look at the trends, the research, your industry in particular, and considered a financial example. What I want to do now is have our first workshop session. So, in your workbook, consider the 2 questions that are on screen now. What are you currently doing to monitor energy use? And what are you currently doing to reduce energy use? Think about what you're currently doing on farm. You may have recently changed tractors and noticed a reduction in fuel cost without even intending to. Once you've considered the 2 questions, turn to page 2 of your energy plan and fill in the yellow box there. While you're at it, have a look at the level 1, level 2 and level 3 data that is required for the National Standards for Energy Auditing, and think about your farm and the kind of data you have for energy use on it. Are you a level 1, a level 2 or even a level 3? We'll talk about it more in the monitoring video. Thank you for taking part in session 1. Your next session is session 2, options for energy efficiency.